Hey, everybody. My name is Matt Doka. I'm the CTO and one of the founders of FiveStars, which is now a SumUp company. And I'm going to be talking today about the three eras of data engineering at our startup FiveStars. I want to start just a little bit about me first and tell you a little bit about FiveStars. So Vic and I founded the company 12 years ago with a mission around helping communities. We were not the social network guys. And so rather than build some really fancy social network app, we decided to build business software. And we realized that by building software for small businesses, which are often a big piece of the heartblood of communities, we could help them connect better to the people in those communities, to their customers, to those organizations they care about, and create tighter knit communities that way. And so 11 years ago, we started on this long journey. The first 5 years were like a rocket ship. The next 6 years were some challenging eras of product market fit, but consistently the whole time, I think we built an incredible technology team that was, at our peak, we've served now 75 million consumers and consumers around the US. We serve tens of thousands of businesses, and I think we do close to $1 billion in processing volume now. And so I spent the first 6 years leading product and engineering and really focusing on building our platform as a marketing platform, really taking a lot of the principles that Starbucks put in their app, making it available to the little guys. And then the last 5 years, launching our payments processor and launching both the compliance and the technology strategy for that, as well as all the vendor negotiation, because as a small startup, you do all that. And in parallel was doing a lot of work reshaping our data engineering org. And when we started, I call it the mess I inherited. Data engineering started at FiveStars as part of really the revenue ops engine and began to serve both revenue and product. And part of that was just because that's how the different systems we procured, that's how they all integrated and that's how they worked. Well, as you can imagine, not having a lot of engineering focus on data engineering can lead to suboptimal practices. And so this is just going to be an overview of some of the things that I saw when I inherited, things that hopefully you don't have in your organizations. But if you look and you study these, should give you confidence that you could go somewhere that's, in our case, was a Series D company when I started doing the data engineering rework, or when data engineering became a thing. It wasn't just part of revenue operations, and when we had to take on a lot of rework there, and that you could do this, that these principles are not that hard to identify or fix, and there's a lot of great tools out there to really help transform the companies and the contexts you're at. And so at the end, I'll highlight some of the best practices, and hopefully you'll walk away with a sense of, wow, I've got I'm at this Ascend thing, right? One of what I consider one of the best tools for fixing a data engineering mess. And I can go make an impact in my organization in a big way. And likely some of these practices are happening there. And even if they're not, I'm going to be using some best-in-class tools that have helped other companies like FiveStars go from moving very slowly with a lot of debt and a lot of problems to operating really cleanly. The first era was the era I inherited. And when I found out I was going to take over the analytics group, which had traditionally reported into revenue ops, but had a little data engineering pod in it, I thought to myself, well, how bad could it be? There's a lot of great tools out there. They're probably using something like Airflow, or Luigi was still popular back then. And I'd heard some buzz about that and didn't think too much of it. But I started to talk about issues and get under the covers as to where they were spending time and where effort was going. And I walked away puzzled, hearing a lot of things like, well, we're checking our emails every day. We have to spend a lot of time reading our emails and fixing jobs. I said, okay, alerting emails, I could see how that's happening, but I should really dive in here and understand what's going on under the hood. This doesn't sound like what I would have expected to hear from a DevOps group. And I'd ask, where's the dashboard that shows how things are running? Oh, dashboard. Well, okay. Well, how do you know things are running? Well, we got these emails. So one fateful weekend, I went on a sales achiever weekend to celebrate our best salespeople. And I, took a download of the code base on my way, and I'd added myself to this email listserv. And on that weekend, I got 50 emails in one day from various jobs with all sorts of different learning and information typologies. I quickly put them in their own inbox subgroup, but started to wonder what's really going on here. How is this thing being run? And on the flight home from Puerto Vallarta, I opened the code and I learned really quickly there was no framework in place, and we had what I consider to be pretty poor practices. And so I'm hoping from this section, you'll walk away with confidence. You're probably doing things better than we did in era one, and then you can go places and make a major impact, just like I did by opening the code, realizing things, and starting to take action. So let me show you what I found that day. I think this is going to be a lot of fun and hopefully confidence building. First, handwritten scripts. This is the thematic of the era. Handwritten scripts. Everything was handwritten Python or shell scripts with lots of duplicate code, because we didn't understand how to use shared libraries or have a shared code base on each machine running ETLs. This cost tons of time and caused mistakes. Some of the inefficient practices we were following: we were spinning up EC2 instances by hand, writing down the instance IDs, saving them into different parts of our code that we're going to then have those jobs run. And we would then manually store GitHub credentials on all these instances so they could pull down code. Not with a tool like Salt or Ansible or even Terraform, not with any DevOps tools. We just literally wrote scripts by hand, told the system to run that pull from Git job, and use that every day. As part of that, and the reason I discovered we had all this duplicate code, rather than sharing libraries, we were copying code into every folder on the repository. And we did this to save space on the end instances, not realizing that most EC2 instances have plenty of space for a couple megabytes of Python code. I think there was close to 100+ versions of send email, which was the function that sent me those 50 emails that day. On top of that, we had no logging or alerting unless you count this email system that was dumping traffic into the inbox every morning. And so our team would have to sift through 30+ emails each day to see if there was issues, to identify issues, which took away time from coding, took away time from building new data pipelines, and slowed and made engineers feel like they were stuck babysitting a fragile system. This cost tons of time, caused errors, and it also made the culture challenging. We had to do all our own DevOps, and we had to do it by SSHing into systems one at a time. Very time consuming. More than that, if we lost somebody, there went the knowledge, except maybe a couple of lines in a side folder of a GitHub repository that referenced what some EC2 instance was supposed to do. Totally not the way you want to run a production system. We also made it very time consuming to develop new software, because we had to copy and paste the code every time. We had to manually spin up instances. We had to do all the DevOps, all of the provisioning, and we had to design the software tailored to each of those DevOps and provisioning considerations. So we couldn't just write software. We had to tie in DevOps code to the software, tie in monitoring the send email code. It also made it really hard to change shared libraries. Switching email providers would require updating 100 files. And as this pile of technical debt and high cost operations grew, it meant one or two of our team members would spend time constantly debugging production issues. Someone had to read those emails every day to make sure the tasks ran, and then have to remember what emails to read. So it was a really difficult environment. People didn't feel like they were making forward progress, and we weren't. We were wasting a lot of time babysitting DevOps, or doing sort of babysitting work for these jobs, where had we had a real framework and a system in place, those jobs would just run. And it made it difficult to develop and to share code, to accelerate development, and to make changes quickly and stably. To get into some fun examples, here is the instructions for how to turn a job on. Spinning up instances in jobs, even the jobs themselves, was done by humans. This is the instructions from readme.md. Go to AWS EC2 instances. This isn't even like provisioned by API. Like literally click into the Cloud Console, click on EC2 instances, choose create new instance, choose this Ubuntu, choose the Ohio region. Please don't forget to choose the Ohio region. That's where we keep all of our instances, and no reason. We just thought that sounded nice. And choose this Ubuntu image and an image type based on your requirements. There's a note in here to make sure you increase the SSD drive memory capacity to at least 20 gigabytes and add a PEM file. That's it. Not the way I recommend spinning up instances. There's no way to audit why an instance exists. There's no way to track your fleet other than maybe the AWS console, and got to hope that everybody follows the steps correctly and that things don't change. On top of that, jobs were referring, or as a result, maybe jobs were referring to where they ran by hard coding the instance names in code. And so as you can see, here's a sample of that code. Use this instance ID, and I guess there's a duplicate of instance ID underscore self. I'm not sure why, to make sure that the code knew where it's supposed to run. So again, there's no separation of concerns there. You're doing DevOps, ETL code, everything all in the same thing. On top of that, staging and production weren't just logic forks in the code, but they were copied. As you can see, here's a couple examples. Our anomaly detection script, and there is an anomaly detection staging script or folder for that job, and same with compliance monitoring and compliance monitoring staging. A lot of copy paste code also inside of these folders. We'll get to that. As you can see from this next note, all of our compliance libraries were copied, not shared. So here's anomaly detection and compliance monitoring. As you can see, they both have AWS instance.py, which is a very DevOps concern. And in this case, unnecessary. This is in the system we had developed, we would tell the code which instances it needed to run on in a system like Airflow, or even better in a system like Ascend. Those DevOps conceptions are handled by the framework. Saves a ton of time. We're not getting into learnings yet, but it's a pet peeve. And then the database connection that most ETL jobs have to do to get their work done. It shows up in every single folder with either the same or slightly different modified code. So rather than sharing a way to connect to the database across the entire platform and code base, we've coded it into each folder. And finally, params, which I think is a way of saying environmental parameters. Again, we've baked the DevOps considerations heavily into the code itself. And as a result, as an unfortunate result, we have a file that manages the environment parameters in every folder. I think in some cases, it's fine to have a master file handle environmental parameters and spin up, or typically just instantiating them from whatever is in the production environment, or for what other production environment makes available for security reasons, right? So you don't have this stuff in your code, in your repository, but we put it in every folder and did it differently. So I was on this plane flight going through this and thinking to myself, oh my gosh, what have I got myself into? Finally, here's an example of the email folder from that era. This is a whole page of 50 emails in Gmail from all sorts of different jobs. It has to be reviewed and made sure that succeeded every morning, so that if jobs didn't work, they could be SSH'd into and reran manually. Where like literally one of our data engineers is having to like log in, rerun a Python script, and waste a ton of time on operational work that isn't pushing the ball forward in our data engineering. So yeah, as you can see here, we had over 50 emails from 331 and the notifications alone for the team to review in the morning to make sure jobs ran. So yeah, that was some tidbits of the first era. All practices I hope that you're already avoiding, but if not, or if you see other companies doing that, it's more common than you might imagine. And there's a lot of great tools to make a quick impact against this. And as I stepped into this role, I began our transition to era 2. the first phase, sort of the first solution. Airflow became our go-to as a framework. That said, even when we started using Airflow, and our Airflow was hosted by Google, we were still dragged down by data DevOps. So when I took over the team, Airflow was really the big game in town to make sure that things were cleanly run. But we spent a lot of time making sure the system was working instead of actually getting work done. What I mean by that is tuning instance requirements, making sure the right libraries could get installed correctly, monitoring the health of the job, running and scheduling workers until we were convinced they could handle our workload fairly sustainably. And still, we had to do a lot of that type of control and DevOps work. But it was a major improvement over, copying, pasting the same code 100 times and having to rerun jobs by SSHing. Once we got Airflow itself running well, it provided a great framework for managing our fleet of jobs. So Airflow did improve things. It gave us a single source of alerting and monitoring. It allowed us to share code instead of copying it everywhere. And much of the DevOps was managed centrally, and much of it was powered by Google. At the same time, Airflow requires time-intensive manual intervention for backfills or when errors left data gaps. The way Airflow gives you so much freedom in designing jobs that every time you hit a backfill problem, you have to design the concept of backfill and partition into your jobs. And every time you have an issue with that, you have to think through the implications to your data backfills as you try to solve gaps from backfills or gaps from when an error took a job down for a few days. In addition, testing parts of a DAG was a painful process when you're developing a new workflow or a new data flow. It took a lot of logging into the console, running a piece of the script, running things end to end was challenging, and rarely were you hooked up to streaming database pieces easily. So you either spent a ton of time trying to make a dev environment really close to production, or you were just iterating a lot in dev, putting it into staging, iterating, and really spending a ton of time rerunning your DAG workflows to make sure that they worked really, really well before leaving them on fully in production. Finally, changes to a DAG required large scale rerun. So if you change the code substantially in a DAG, you'd have to do a large rerun across typically the entire pipeline, because this notion of stepwise components of a DAG only exist if you thought ahead and coded it in and had that in your framework. Airflow by default doesn't provide that notion of phasing, and so would spend a lot of time, or made us reticent to change code, even when you could come up with a better way of doing a job or part of a job. If you change the code, you're taking on this whole backfill historical problem, and it makes you more likely to say, let's just figure out a way to live with it. As part of that flexibility that Airflow offered, you could do things many different ways. And often as we crank through jobs, every job had its own flavor, its own style. And so it meant that learning what somebody else's job did took a lot of time instead of being able to follow a common pattern, even when it came down to the actual code itself, because there are different ways to generate DAGs. Some people auto-generate DAGs or auto-generate components. And one of the workflows I'm porting over to Ascend right now was done in one of these new ways. And so this person's preferred way of doing something. And it just adds a lot of time and overhead when you're trying to ramp up on someone else's work. And at the end of the day, we spent a lot of work setting up our dev environments and managing the dev, staging, and prod pipelines. So we had to work hard. It took a lot of work to set up a dev environment and took a lot of work to shepherd code into production. Once it ran pretty stably, and it was definitely an improvement over Era 1. So we did gain central management. It's really nice compared to an inbox full of 50 emails. But backfills to address changes or job run errors cost time and were hard to manage. So as you can see, this is where a lot of the backfill issues came up. Like Here's one of our data engineers. Me and Swagat will be working over the next week to restore the backups and backfill his data in Redshift. This was a week plus of babysitting work, just managing backfill of one table after logic was complete. And so the code was done. And now our data engineer's time is being spent running it correctly for the backfill. Not thought really work. It's just DevOps, data DevOps work. Not some, if I could avoid it, I would. And with Ascend, this is the secret. With Ascend, we do. The message table is deprecated. The aggregate table is still backfilling, unfortunately. Slow backfills would delay analytics team. There was no way to scale this up easily. It was such a lot of work to get Google Cloud Composer tuned to the right parameters just to run Airflow as it was, that accelerating a backfill and the logic that would take to think about parallelization or anything was another burden of work. And we just decided, I think rightfully in this case, we would always decide, let's just let the backfill take its time. It's not urgent enough to take all the work it's going to take to make another, to find another method. And this great gem, can you please advise how far back the backfill has to go and when will this be completed? Oh, well, it can only go back to 9/23. Who knows why, but for April data, I can manually backfill them first. I can get you that before the end of day tomorrow. So this backfill wasn't complete. It was difficult to get a complete backfill done, and parts had to be done manually. We're wasting a ton of time hand-holding backfills, doing manual data DevOps work, when really what we want to do are build solid ETLs and analytics tables and make progress on our core business. And on top of that, we had to spend a lot of time on operational concerns, like where data should go and what size instances we should run. Here's this. So here's a bunch of tables. We're migrating them all to S3 under this new schema because size is a major consideration and it's going to take a lot of work. And then, so this is like, where does the data go? Does it go to S3? Does it go to Redshift? And it takes a lot of work every time you want to change destinations or even think through the larger tables. And again, one of the beauties of a system like Ascend is that every stage of the job has its data right there. As you complete the job, you've thought about the data schema and where it goes as an afterthought. You can leave it in S3. You can also dump it into Redshift. And the kind of system I was looking for was one where data engineering does thoughtful data schema work and data transform work. And a system that we don't have to reinvent handles everything else. Like, where does it get stored? Where do I want it to get stored? Or at the very least, it's a quick flick of a switch to change things. We spent a lot of time getting this configuration right. 3 nodes, 100 gigabyte disk, and 2 standard 8s. Doesn't tell you, when we started with Airflow, we were using a weaker machine type. Nobody had a clear idea of what spec you should use to run it. Google gave you a pick of everything. And as a result, it was really difficult to decide. And we under provisioned. It cost us a bunch of time figuring out what had broken or what we were doing wrong. And until we finally realized, okay, if we do these worker nodes and decide this is going to be a better, more performant environment for us. And as a result of having to judge what type of instances we needed to use and make a bunch of hardware and DevOps decisions, we had to watch things like the environment health, database health, the things that wouldn't take care of themselves. Finally, our dev environment startup was still quite long. So we weren't owning the AWS console anymore. We still had a long quick start guide of how do you get set up to do your first ETL job and get it into production. The good news is we finally entered a third era where Ascend solved both our framework and our data DevOps issues. Ascend, like Airflow, provided a framework and tool powered approach, but also handled all the data DevOps so we could focus on building fast. I'm just going to go quickly through some of these major improvements above what Airflow is able to do. As we develop, we can see data results immediately and automatically. I can't underscore how nice it is at each step of your DAG as you're developing to know exactly what's coming out. It speeds up 10x compared to alt tabbing between a bunch of consoles or putting a bunch of print and logging statements into your Airflow code, your Airflow Python code. Ascend handles spin up and spin down of the environment based on your budget. So you don't have to do any DevOps. I don't have to figure out how many systems I need to provision. I don't have to watch how hot the cluster is getting. You can drag and drop your components, which as you're designing DAGs is a very useful tool to visually see how each piece of your design fits together. On top of that, those components are built into both output data in a consistent schema and be parallelizable. So, and have partitions built in. So as you complete the data work, as long as you follow the framework, and typically Ascend kind of forces you a bit to do that, but you don't have to worry about what do I do about 3 days ago? Or if a job is turned off, how do I handle the 3 days it wasn't on? Or what happens when I change a piece of the code? And then finally, what is the different data? What does the data model look like at each step? All of that's handled by drag and drop visual components. And by following the framework, when you complete the code portion, like the coding and thought portion of your data engineering work, the rest, the system, the Ascend system is able to handle the rest. And again, save you a lot of DevOps time, backfill time, babysitting, data engineering job time. And finally, it makes it really easy to see and debug the broken DAG parts. And when you do, the operational consideration of how do you recover is typically handled for you because of the partition logic that's built into Ascend. So in a nutshell, our first era, everything was done by hand, a lot of manual scripts, no frameworks, no consistent way of doing things, tons of time on DevOps, tons of time fixing bugs, very little time to do actual data engineering. In the second era, Airflow was a huge step forward in doing things more one way, still a lot of flexibility, too much flexibility in the framework, and a lot of work doing data engineering or data DevOps, but enabled us to start having a consistent operating cadence and saved us some of that DevOps work. And then in the final era, our third era, our current era, Ascend not only provided a consistent framework for how to do data engineering work, it also, in exchange for following that framework, provided all of the data DevOps, the backfill DevOps that were needed to run things. And I'm right, like who wants to be the 1,000th and first company to get to spend time figuring out how do I run my data engineering system? Instead, Ascend handles all that. We're able to do what we do best, which is data engineering, building product. So just wanted to say thanks to everyone for sticking around with me today and for coming to the talk. And I'm looking forward to Q&A with you shortly.